A rectangle contains a circle. From each corner of the rectangle, construct a tangent line to the circle. Starting from the northeast corner, the lengths of the tangent lines are equal to 46, 31, 34, and x. The question is to solve for the length x. Pause the video if you'd like to give this problem a try, and when you're ready, keep watching to learn how to solve this problem. Let's get started by labeling the diagram. Call the rectangle ABCD, say the circle has center P, and label the tangent points as E, F, G, and H. Construct triangle AEP. Since AE is a tangent to the circle, AE is perpendicular to EP. Since we have a right triangle, AE squared plus EP squared is equal to AP squared. Let the radius of the circle be equal to r, so that EP is equal to r. Substituting in, we have 46 squared plus r squared is equal to AP squared. Let's do a similar construction for the remaining three tangent lines. Construct the triangle BFP. Since BF is a tangent to the circle, BF is perpendicular to FP. FP is the radius of the circle, so its length is equal to r. So in this right triangle, we have 31 squared plus r squared is equal to BP squared. Now construct the right triangle CGP. GP is equal to r, so we have 34 squared plus r squared is equal to CP squared. Finally, construct the right triangle DHP, where HP is equal to r. Thus we have x squared plus r squared is equal to DP squared. So at first it looks like we've just made the problem more complicated. But we notice something. We have a pattern. On the right-hand side, we have the square of distances from each corner to the center of the circle. So let's see if we can work out a relationship between these squared distances. To do that, we will use coordinate geometry. We'll let C be the origin 0, 0. Let P have coordinates PQ. Let D have coordinates D0, and let B have coordinates 0B. Since ABCD is a rectangle, A has coordinates D, B. Now construct AP. Let's calculate the squared distance of AP. We can do the square of the distance formula to get that this is equal to the square of D minus P plus the square of B minus Q. Let's do the same thing for BP. The square of the distance BP is equal to P squared plus the square of B minus Q. Do the same thing for CP. This squared distance will be equal to P squared plus Q squared. And finally, we calculate the square of the distance DP. This will be equal to the square of D minus P plus Q squared. By simple inspection, we can see that the square of AP plus the square of CP is equal to the square of BP plus the square of DP, and both of these are equal to P squared plus Q squared plus D minus P squared plus B minus Q squared. So this gives us an equation. We now know what AP squared, CP squared, BP squared, and DP squared are equal to in terms of r squared, so we can substitute in from those four equations we've derived. So we have 46 squared plus r squared plus 34 squared plus r squared is equal to 31 squared plus r squared plus x squared plus r squared. We have 2r squared on both sides, so we can cancel this out. So we are left with 46 squared plus 34 squared is equal to 31 squared plus x squared. We want x to be a non-negative length, so we will take the non-negative square root. So x is equal to the square root of 46 squared plus 34 squared minus 31 squared, and that is equal to the square root of 2,311, which is approximately equal to 48.073. And that's the answer.